Hi guys, I just want to go through a quick brief discussion on earthing conductor thicknesses in South Africa. So the standard states that we are allowed to use a 1-to-1 ratio up until 16 millimeters squared. From 16 to 35 we use 16 millimeters squared, and then from 35 and up we use a 1 to 0.5 ratio, meaning that if your phase conductor is say 70 millimeters squared, then you use a 35 millimeter earth. All right, so these are the standards that most of you know. But the thing is, like, a lot of you are saying that you use 1.5 millimeter earth with your 2.5 millimeter wiring within the installation. Is that correct? Well, let's go and look at the adiabatic equation before we decide that that is quite correct.
Hi guys, welcome back. So today we're just going to go through the adiabatic equation for calculating protective earth when you have the protection time of your protected device. Alright, so let's just go through a few things over here. S in the calculation is the conductor size in millimeters squared. I is your PSC measured at your control point. T is time taken depending on your spec of your circuit breaker, alright? So the B spec will trip between 3 to 5 times its rated current. It'll trip instantaneously. This means it'll trip from 0.01 seconds to 0.1 seconds. That'll be the trip time, is the actual equation. So when we take our PSC, we take a look at typical values. So we got a PSC of 1.2 kA. We have a B spec curve, which means it's going to trip in this time, especially with that amount of current. So 0.1 to 0.01 seconds. Okay, there's our 1200 amp PSC. Over here is our trip time, and over here is our K rating, the PVC insulated copper. Alright, so when we calculate it, it comes out at 2.3 millimeters squared required for this installation. It's basically exceeding its thermal limits. So over here, we got a recalculation with a PSC of 500 amps, and we basically come to the conclusion that we could use 1 millimeter square earth. Sometimes the 1.5 millimeter would be enough, other times it will actually technically not be enough. It's more like a guess than really an engineering calculation.